Hello all, we'll see the next topic of theory of computation, that is acceptability of a string by finite automata. We'll see what do mean by acceptability of a string. Now definition is given that a string x is accepted by a finite automaton m equal to q sigma delta q0 f if delta q0 comma x equal to q for some q belongs to f. Now what is the meaning of this definition? It means here we have to find out the given string is accepted or not, and this is the acceptability of a string by final state. It means we have to find out the acceptability of a string by final state only. Now what is the meaning of this definition? Suppose x is accepted. When we can say that this x is accepted or not by given finite automata if delta q0x, this transition is given here. It means q0 is the initial state. It means we can start from initial state for the given string. It gives q for some q belongs to f, means q is final state. It means if one of the string which start from initial state and it end at final state, that string is accepted by given finite automata. Now we'll see one example. Suppose this transition diagram is given. This is initial state and Q2 is final state. And here string means we start from initial state and it must end at final state. That string is accepted. It means basically here we have to find out the path for the given input symbols. So your string should be in the form of input symbols, that is input alphabet. So here input alphabet is what? 0 and 1. It means here for this diagram your string should be in the form 0 and 1 only. So we can find out the accepted string. It means basically here we have to find out the path which start from initial state, it must end at final state. So we can start from q0. So q0 goes to q1 for 0. So we get the first path is 0. Then from q1 it goes to q2 for 1. It means anyhow we have to use this transition. So 0 1, it means we get this path 0 1. So that is the string, and this string is known as accepted string. Suppose self loop transitions are given. So meaning of these self loop transitions are that we can use these transitions 0 or number of times. It means as per the requirement we can use these transitions. So meaning is that it means for going from initial to final state, sometimes we do not use these self loop transitions. Suppose we have to find out the string 001, is this string is accepted or not from this diagram. We have to find out this. So 001. So basically we have the path for 01, last two symbols, only first 0 is required. So at that time we can use these self loop transitions. It means our path is q0 goes to again q0 for 0, again next is 0 we want. So anyhow we have to go from this to this. So it goes to q1 for again 0, again q1 goes to q2 for 1. It means we can use this path for finding this accepted string. It means if self loop transitions are given, we can use it 0 or number of times. Again, suppose this string is given. So it means again one more 0 is required. So already we have path for this last symbol 001. Again, one more 0 is required. If self loop transitions are given, we can use it number of times also as per the requirement. So again, for this 0 we use one more self loop transitions 0. It means we can say that this string is also accepted by this diagram. Again, self loop transition is given for Q1 and self loop transitions are given for Q2. So here two symbols are given as a self loop for Q2. Again we have to find out that 01 string is accepted or not from this diagram. So here when we can say that the string is accepted or not, the string which starts from initial state, it must end at final state. It means for 0 we can use this transition and for 1 we can use this transition. No need to use these self loop transitions because anyhow we have to use this path. We have to start from initial, we have to end at final state. It means anyhow we have to use these two transitions 0 1. So this string is accepted. Again 0 1 1 1 is added here. So we have already path for 0 1 and last one we can use again this self loop transitions for 1. It means your path is Q0 Q1 Q2 again Q2. It means we are using this self loop transitions for this string. It means this string is also accepted. So in this way we can find out the acceptability of a string by final state. We'll see how to write the sequence for acceptability. We'll see one example. Consider transition table. Find out the acceptability so here transition table is given. So here transition table is given. We have to find out that this string is accepted or not. If transition diagram is given, roughly we can find out the path and we can find out the acceptability of any string. But if table is given, we need to write the sequence for acceptability. So here we can observe that this table is DF because no more than one states are given in these entries. So if DFA table is given, we can write the sequence easily. Now for this string, so anyhow we have to find out this string which start from initial state, it must end at final state. So we can write the sequence in the form of transitions functions. Delta, we can start from initial state is Q0. We can write the given string. Now we'll write the sequence one by one. We'll write Q0. First symbol is 1. It means here we have to find out the transition of Q01. So Q01 is what? Q1. So we'll write here Q1. and remaining symbol as it is will write. Then Q1 1. Q1 1 is again Q0, remaining symbol Q0 0. Q0 0 is Q2, remaining symbol as it is will write. Q2 1. Q2 1 is Q3. Then 0 1 is remaining. Q3 0 is Q1 and only 1 is remaining. Now the last transition is Q1 1. So what is Q1 1 is Q0. It means finally we get the Q0 and Q0 is final state. So it means we can say that this string is accepted. So accepted means what? That string we start from initial state and it must end at final state. That string is known as accepted string by final state.